Hi, this is Shamleshwar. I am from Triple E Department. I am doing first BTech second semester CA to assignment. Subject name Chemistry. Subject code 23CH01. My topic is Principle and Applications of NMR Spectroscopy. Introduction to NMR Spectroscopy. Nuclear magnetic resonance spectroscopy is a powerful analytical technique to used to study the molecular structure of organic compounds. It is based on the principle of nuclear spins aligning in a magnetic field and absorbing or emitting electromagnetic radiation at specific frequencies. NMR spectroscopy is non-destructive and provides detailed information about the chemical environment of atoms in a compound. Next, principle of NMR spectroscopy. Nuclei with an odd number of protons or neutrons possess a nuclear spin and behave like tiny magnets. When placed in a magnetic field, these nuclei align either parallel or anti-parallel to the magnetic field. By applying radio frequency pulses, the nuclei can be excited to the higher energy state and then relax back, emitting the signals that are detected. NMR spectroscopy instrumentation. NMR spectrometer consists of a powerful magnet to align nuclear spins, radio frequency coils for excitation, and detectors to record signals. The sample is placed in a tube and inserted into the NMR spectrometer, where it is exposed to the magnetic field and radio frequency pulses. The signals emitted by the nuclei are processed to generate a spectrum that reveals the chemical structure of the sample. Next, chemical shift in NMR spectroscopy. The chemical shift in NMR spectroscopy refers to resonance frequency of nuclei relative to standard reference compound. It is influenced by the electronic environment surroundings to nucleus, with different chemical group exhibiting unique chemical shifts. Chemical shift values are reported in part per million and provides information about the chemical structure and environment of the nucleus. Next, spin coupling in NMR spectroscopy. Spin coupling occurs when the magnetic field generated by one nucleus affects the resonance frequency of neighboring nucleus. These phenomena result in the splitting of NMR signals into multiplets, providing information about the number of neighboring nucleus. The pattern of splitting, known as coupling constant, can be used to determine the conductivity of atoms in a molecule. Next, applications of NMR spectroscopy in chemistry. NMR spectroscopy is widely used in organic chemistry to determine the structure and purity of organic compounds. It is valuable in identifying unknown compounds, elucidating reaction and chemism, and studying molecular conformations. NMR spectroscopy is also employed in pharmaceutical analysis and metabolomic and material science for molecular characterization. Next, application of NMR spectroscopy in biology. In biological research, NMR spectroscopy is utilized to study protein structures, interacts, and dynamics. It can provide insight into enzyme mechanism, protein folding, and drug-protein interaction. NMR spectroscopy is vital in structural biology and drug discovery, offering detailed information about biomolecular system. Next, advanced technique in NMR spectroscopy. High resolution NMR spectroscopy allows for detailed analysis of complex organic molecule with multi-signals. Two-dimensional NMR techniques such as COSY, HMQC, and NOESY provides additional information about proton and proton carbon conductivity. Solid state NMR spectroscopy is used to study materials with limited molecular motion such as polymers, catalysts, and biomolecules. Future trends in NMR spectroscopy. Advanced in NMR instrumentation such as cryogenic probes and higher magnetic field continue to improve sensitivity and resolutions. The integration of NMR with other analytical techniques like mass spectrometry and X-ray crystallography enhance structural elucidation. NMR spectroscopy is evolving towards in cell and in vivo applications, enabling the study of biological systems in their native environments. Conclusion: NMR spectroscopy is a best analytical to that provides valuable information about the structure and dynamical of molecules. Its applications can span across chemistry, biological, material science, and pharmaceutical research. Continued advancement in NMR technology are expected to further expand and capability and reach of their indispensable analytical techniques. Thank you.